Hello, so welcome to another video on how to solve ODE in MATLAB. So in this video, we are going to go through how to solve ODEs in MATLAB. So the most common approach that is used is to use ODE 45, even though there are some other ODEs that you could use, or other solvers that you can use. So the ODE 45 is a variable step longitudinal solver. So this is just one of them. There are some other ones. So it follows a similar approach. So for higher or other ODEs, so if you want to solve higher other ODEs, you will need to first decompose that higher order ODEs into a system of first order ODEs and then do the same thing. So, for example, if you want to solve second order differential equation like d squared y dt squared equals something. So you have to first define another function. So define an equation if a variable y, for example, to be equal to, okay, let's say you want to solve d square x over dt squared equals something. So let's say you define y as x, y as dx dt. So you first define a variable that represents the first order derivative, and then you differentiate that variable in order to get the second order derivative. I hope that makes sense. So that when you differentiate y, then it gives you d square x dt squared. So, so you will need to have these two equations in your model. Now, the standard syntax is that you have two square brackets. So you have the t comma y, for example, then the solver, ODE 45. In this case, the function that's called ODE fun, TS span, so that's the time span, how long you want to run, and why not, initial condition, and options, some other settings that you want to do. Now, um, in the function that I just showed you, these are the parameters. So ODE fun is a function handle that defines the differential equation. Basically, this is what defines the equation that you want to solve. So that function will accept at least two inputs, so t and y, and will return a vector of the differential variable. So derivative of the differential variable, so dy dt. So t span is a time interval for integration, and it could be specified as a range. So you could have it as, let's say you want to run from 0 to 5. So the starting point, finish point. So T naught is the starting point. TF is the final time. So let's say you want to do 0 to 5. So this will be 0 and this will be 5. Or you can specify the range or the time as specific time stamp as a vector of specific time that you want to run. We want to evaluate that function within that range. So instead of saying 0 to 5, you can say 0, 0 0.5, 1, 1.5, 2, 2.5, and so on, and specify that as a vector. Or you can also use some other function like lane space to do this automatically for you. So you just need to specify the starting point, the finish point, and how many points you want to generate between those two intervals. So why not is the vector containing the initial conditions for each state variable at time t equals 0. So at time t naught. So at the initial point, so you need to specify the initial condition. So the value of your differential variables, in most cases, at time t equals 0. So if you have three differential equations, for example, you need three initial conditions. So options this is optional and can be used to adjust solver performance. So output is going to be t and y. So t is a vector, is a column vector containing the time steps where the solution was evaluated. So this t will just store this t span, for example. And y would just be the value of y, is a matrix that will store the value of y that correspond to each time stamp that you have in this vector t. Okay, so for example, in MATLAB, the @ symbol is used to define a function handle, and when it is and then when it is followed directly by an input list and an expression, then it is followed by an input list and an expression. So this is used to create an anonymous function. So what does it mean? Anonymous because it doesn't have a name. It doesn't have a separate name that is stored on a file. So let's say, for example, you have f equals @ x. So this x is basically the input argument, and this is the expression, which is basically the right-hand side of your differential equation. So here, art tells MATLAB that a function is being defined, x, specify the input argument, and this is the expression, which is the function that you want to solve. Then the function is called anonymous, as I said before, because it doesn't have a name in a separate file. So anonymous functions are commonly used with ODE solvers because ODE 45 will expect you to provide just two arguments when you call it. So when you do the function call, you are expected to pass two arguments. But in some cases, you might have more than two arguments. So maybe there's some other parameters that you need to pass. So in this case, it's just a way of bypassing that the problem that you might have when you need to pass more than two parameters. Now, let's say, for example, you have this code. You already defined two parameters, and then in your model, you have t, y, a, and b. So you have four parameters in your model. So, and the OD45, we expect t and y as the parameters to pass. So what will happen is that when OD45 calls the function, so it only passes t and y as argument. So, and the other values of a and b will be grabbed automatically from out the surrounding workspace. Okay. Now let's say this is an example. So this is a differential equation. Dy dt equals 7 minus 2y. That's what you were trying to solve. So we've written the function. So this is the anonymous function. My ODE equals at t comma y 7 minus 2y. And then is the initial condition. This is the time span. So you want to run from 0 to 5. And t underscore eval is basically your time, the specific time points that you want to evaluate that function. So you're saying from 0 to 5, but you need 100 points between 0 and 5. Then you call the numerical solver. So t comma y, this will be your output, and is equal to the solver, the function, the time you want to evaluate, and then the initial condition. And then when you run it, this is just plotting the result. And when you run it, you will generate the result that looks like that. So that's how to solve ODE in MATLAB. So that's it for this video, and I will see you in the next. Bye-bye.